we are going to be talking about section 3.5. This section is about the derivatives of trigonometric functions. As you would see, we are going to start with the sine x. The derivative of sine x is cosine. You can easily find this formulation by using the limit definition of the derivative. But since these formulas are given to you, you don't have to take the limit definition of the, you don't have to use the limit definition of the derivative to show that. So I'm going to just tell you that this is what it is. The derivative of the sine x is equal to cosine x. And the derivative of the cosine x is negative of the sine x, as you will see here. And let's look at the graphs and the derivative of the graph of the derivative of cosine. It is good to practice on this because, look, y is equal to cosine x is, as you would know, the blue colored graph. Let's look at the horizontal tangents, because the first thing, if you want to draw the graph of f prime, you should first look at where you have the horizontal tangents. And here, as you will see, we have a horizontal tangent at negative pi, 0, pi, and powers of pi, actually. 2 pi, integer powers of pi. So it's going to be 2 pi, 3 pi, 5 pi, 6 pi, etc. Similarly, negative pi, negative 2 pi, negative 3 pi, we are going to all have these horizontal tangents. What happens at horizontal tangents? The derivative is 0. So at 0, we expect that the derivative of f, which is cosine, to be 0. And similarly, at pi, the derivative is 0. At negative pi, the derivative is 0. The rest, we just look at, for example, let's look at negative pi to 0 for cosine x. You will see that the function is increasing and a tangent line has a positive slope. So this tells us that between negative pi and 0, the derivative is going to take positive values. So you can draw a curve like that. On the other hand, between 0 and pi, the function is decreasing. Decreasing means the derivative is less than 0. Negative slopes. Negative slopes means the derivative of that function, which is negative sine x, is going to take negative values. So between 0 and pi, which we already fixed at 0 and pi, it's going to be 0, but in between, the values are going to be negative values. So you continue like that and you end up with such a graph. But we already actually know, since we know the derivative of cosine is negative sine, and we know how to draw the graph of sine, and negative of a function is the reflection. So you can also draw the same graph by drawing a sine function and take a reflection along the x-axis. So there are two ways to draw the graph of the derivative of f in this case. But this is going to be true only for this cosine x function. Okay? But for arbitrary function, if you want to draw the graph of a function, graph of the derivative of a function, you have to start with the horizontal tangents where they happen, and then you just plot these zeros of f prime, and then look where the function is increasing, decreasing. If a original function is decreasing, then the derivative is positive, so you're going to have a positive graph like in here. If the slopes are negative, then in such an interval 0 to pi, you expect that the derivative is going to take negative values. So that's how you should actually pay attention how to draw that. Okay, this is about spring. There's a vertical spring and there's a rest position here. 0 is this rest position. So when you have, since it's a spring, it's going to go up and down, and the maximum it can go is until 5. The minimum it can squeeze is negative 5. Positive 5 is the most. Okay, so it's going to start at position t is equal to 0. We have a stretch on the spring and we leave it. It's going to go until negative 5. And then it's going to go up and down, and then it's going to stop at 0 eventually. It's the rest position. Okay, we have some questions like that. Example 3 is an example. So you can take a look at this example in our book, what type of question it has. Okay. In the problem actually, which we don't have hit here, probably if we go back to here, the distance function is s is equal to 5 cosine t. So in other words, this displacement, this moving up and down, it's the displacement position, or position function, we can say. It is represented as s is equal to 5 cosine t. And then if you take the derivative of this, you're going to get negative 5 sine t. And the graph is like this. You can again draw the graph by taking the reflection, by multiplying by 5, the regular sine function. Okay, so for example, this is going to tell us this s function is just shows the position of the spring. So it's, for example, 0, it's the when time t is equal to 0, it is at the position 5 meters, whatever the unit. Let's go back and check. It doesn't say. Okay, 5 centimeters. Okay, it's 0. And then at pi over 2, and again it is at pi over 2, it is at rest, and time t is equal to pi over 2, and time t is equal to pi, it is going to squeeze until negative 5, and then it's going to go up and down like this. Okay, and what we get with the derivative here, so the blue one is the position function, while the red one is the velocity of the object, that weight that we have, right? It's gonna go up and down, so it has a speed. So the red colored graph is going to show the speed of the object. Okay, let's continue with the derivatives of other trigonometric functions. Tangent, secant, cotangent, and cosecant are important for us. If you take the derivative of tangent, you are going to get secant squared x. If you take the derivative of secant x, you get secant x tangent x. If you take the derivative of cotangent x, it's very similar to tangent. It's just a negative of the cosecant squared x. And the derivative of cosecant x is negative cosecant x and cotangent x. This table is a nice table because it's going to show us the similarity. So whenever we remember tangent, the derivative is secant squared x, whereas cotangent, which is the reciprocal of tangent, the derivative is negative cosecant squared x. So very symmetric. Similarly, for secant x, the derivative is secant x tangent x. For cosecant x, the derivative is negative cosecant cotangent x. Very symmetric formulas. It is easy to remember. Okay. We will talk about 3.6 in our next video.